Let's see how we can use confinement to prevent race conditions. So instead of sharing a single status object across multiple threads, we're going to have each thread work with its own status object. So let's remove this global status object and remove it from here as well. Now we go into constructor of this class and remove this parameter, and then set the status field to a new download status object. Now, back to our demo class. So we start 10 threads, we wait for them to finish. At the end, we have to ask each thread for its status object. Then we'll combine the total bytes across all these status objects. But there's a problem here. We're creating our download tasks over here. So later on, we won't have access to them. Now, to solve this, we're going to create a list of download file task objects. And every time we create a new download file task, we're going to add it to that list. So let's create a list of download file task. We call it tasks and set it to a new array list. Now, in our for loop, first we create a task object, new download file task. Then we add it to our list. So tasks.add task. And now we can pass that object over here. That's better. Now, after all these threads are finished, we need to combine the total bytes across these tasks. So we go back to our download file task class and create a getter for this field so we can read it later on. We put the caret on the field name and bring up the generate palette to create a getter for this field. So here's our getter, getStatus, which returns the status field. Now, as a best practice, move these getters and setters down the bottom. This makes our code cleaner and easier to read. So first we list our fields, then we have our constructors, then we have our public methods, and finally we have our getters and setters. So let's move this down. There you go. So after the run method, we have our getter. Now, back to our demo class. Here we can use the streams API to combine the total bytes across these tasks. So we go to our tasks list, get a stream, then map each task to the total bytes it has downloaded. So map, we pass a lambda, t goes to t.getStatus, and then we get the total bytes. With this, we get a stream of integers. Now we can reduce this integer. So we call reduce. We can pass an initial value and then a binary operator. For example, a and b goes to a plus b. Or we can rewrite this as integer sum. So we use a method reference here. With this, we get the total bytes. So let's store it over here and then print it on a terminal. As simple as that. Take a look. So we have 100,000 bytes. If we run this program again, we get the exact same result. So we no longer have a race condition because these threads are not modifying a shared object.